Welcome to this episode of Robots in Depth. Today I'm honored to have Sebastian Weisenburger from TUM here, and he also works with the ECHORD++ project.
Exactly.
I'm going to start it the way we usually start it. How did you get into robotics? Why robotics? Why not something else?
Well, it was an interesting story. So I used to work for a German member of parliament who wasn't re-elected, and I was looking for a new job, and I saw the job offer by TUM that they were looking for someone doing public relations in robotics, and I had a friend there who was actually working at the very same place, and she told me, yeah, that's actually where I'm working at, and why don't you hand in your application? And I did. They took me, and so that's why I'm here.
Yeah. How long time ago was this?
That was 2.5 years ago.
Yeah. So that was just the beginning of this robot revolution. We're seeing that's when the real growth phase started. So you've been part of robotics for a very interesting phase, I think.
Yes, exactly.
And you also come from a quite different background than the usual people I interview, bringing in the political experience and a total different set of previous history.
That's true. I got a master's degree in philosophy, communication studies, and political science, and I used to work in politics for quite some time. But that's also what makes it easy for me to work as a PR person in robotics now, because my main job is to translate what the scientists and the researchers are saying into a language that the general public can understand. So if I was, let's say, a mechanical engineer or a computer scientist by profession, I think it would be harder for me to step out of that picture and think about, okay, what is it what normal people can understand, and what is jargon that should be translated into something else.
Yeah, that's exactly what I'm thinking we need much more of than we have today, because you can spend the time immersing yourself in the field, ingesting this material and then reprocessing it for the general public and also for politicians, which is a very important demographic. For robotics really have to keep a dialogue open with the regulatory industry and the politicians.
No, it's very important also for ECHORD++, and I can say we're fairly well connected. So we had a booth at Hannover Messe, and we had 2 European commissioners coming by for visit. So and also at Automatica 2014 there was the former European Commissioner for Digital Innovation, Neelie Kroes, and she was at our booth too. So we like to tell the decision makers what our project is about and where we see the future trends in robotics, so they can actually pave the path towards the future of robotics. And it's, of course, let's be honest here, is also about structuring where the funds for future research and development will go to.
And also, so the funding research, funding development, funding market introduction, which is challenging for the European Union, that last step, but also preparing the regulatory framework that we operate in. We see this in the drone space where regulatory stuff is just decades behind. You have the same regulatory thing for a 747 as you have for a drone, and they're wildly different things.
Yeah, completely different. I mean, especially for me as a philosopher, that's very interesting when you talk about ethics in robotics. Who is responsible for, let's say, what autonomous systems are doing? Is it the user? Is it the manufacturer? Is it maybe someone else? Who is responsibility assigned? So all the ethical and legal questions that are around robotics, I'm interested in them very much, but this is more the private part, because I don't hit them that much in my actual daily work.
But I think you're going to do so more and more, because as robotics are introduced in the general population and in general society, we're going to see much more thinking about how can we do this well, how can we do this for the benefit of each other and the society we live in and with the society we share, right?
That is definitely that is definitely true, especially as we're going into the field of medical robotics in ECHORD++, rehabilitation at home, also robots for the use in hospitals. So there is always a part of proposal writing is about stating what are you going to do with ethical issues, because every time there is some kind of robot-patient interaction, ethical issues, they occur immediately, and so you have to be able to challenge them, to find an answer to them. For example, let me say data protection. So you're collecting a lot of data from patients, and how are they stored? How can you make secure that no one else can access the data than the people that are supposed to access that data? That's a very important question.
One example I've seen is that we take cleaning in a hospital room. We can have a person doing it, and we can have a robot doing it. If you are in the hospital and you're getting treatment, you have a right to privacy.
Yes.
And a person might see you, and then they might share that information with somebody that you don't want them to share it with.
Right.
But a robot also has sensors. They have sensors for video cameras,
exactly.
sound.
Exactly.
They might also actively, constantly transmit that data to the server for processing. And how do we protect this?
That's a very good question. I mean, there have to be rules, legal frameworks. It's not all about trusting people, but also about setting up the right rules, also from the political perspective. So what you can actually do and what you can't do. So it's not only about hospital rooms. If you think about like something that is very harmless, like robots for tourism. So a tourist guide that's roaming around the city, and you can ask the robot questions, maybe in several languages, and the robot will direct you to the nearest restaurant, cafe, the nearest site. So that all sounds very fine, but of course there's the risk. So you could misuse this as a police robot, so access the camera and see what people are doing on the street and supervise them. So I mean, in several countries you have CCTV all over the place, but for us in Germany, it's very important that there, even in the public space, that there are some places that are not supervised 24/7. So, and it has to be made sure that these robots are only used for the purpose they're supposed to be used for, which is in that example tourism, and that the data won't go to the police or someone else.
And even if it does go to the police, it has to do so in a controlled way, and it has to be accountable. You have to know who accessed what data and when and why, and if it is for instance, for law enforcement, it has to also be supervised by, for instance, a judge or some third party,
an independent party. Yes.
Yes, that has both the interest of law enforcement and the general public in mind when they're doing this very hard trade-off.
Yeah.
You're now working with. Should we do TUM, Technical University of Munich? We're at the Munich Fair this time, and we really appreciate both the support of KUKA and the support of the Messe Munich to allow us to be here. Could we look a little bit on what you do for TUM?
So I'm working for the ECHORD++ project, which is a EU-funded robotics research project. So what we did basically is we collected money from the European Union, and we are now redistributing it to fund application-oriented research. So in close collaboration of industry, academia, and the users of the technology, our motto is from lab to market. So that's what we do. We bring robotics technology from the lab to the market.
Very interesting. And you've been doing this for 2 years now, I understand.
2.5 years.
2.5 years. And the project is 4 or 5 years in total.
It's a 5 years project. So ECHORD++ is the follow-up project of the first ECHORD project, which lasted already for 5 years and ended in 2013. So in autumn 2013, ECHORD++ came into place, and it will last until the end of September 2018. So then after that phase, we had 10 years of ECHORD projects in total.
And I'm sure there's going to be a continuation in some shape. It would be totally crazy not to fund further development of robotics now.
You tell that to the European Commission.
Oh, yeah, I can
Hello, Commission.
Hello, Commissioner. I can definitely do that straight to camera. Not supporting this because I see this in two ways. I see that Europe really stands well when it comes to research. Our research here in Europe is very well, very good. And I also see that transferring these results to the general domain, either spinning it out as companies, transferring it to existing companies, working with existing companies of having them pull technology from research, say this is what we can use, this is what I need, can you help me? and cooperating with industry is something we need more of, not less of. You heard that, Commission.
Yeah, that's you're absolutely right on that. That's a very important thing that you say. Not everyone is working in their world and they don't know the other worlds. It's about talking to each other. It's about robot manufacturers talking to researchers and exchanging ideas, exchanging needs, and also about the users actually of the technology to take in what they want, what robot technology actually they need. So we have a part of ECHORD++ is the so-called PDTI, Public End User Driven Technological Innovation Scheme. It's a horrible acronym.
The gist of it is nice.
Yeah,
what you're trying to do.
The idea is very, very interesting. So we asked several public bodies like municipalities, hospitals, for example, what kind of needs they have, what problems they have they would like to solve with robotics technologies. And then an independent panel asked, they evaluated those channels, and then they came out with two challenges that are very important. One is sewer inspections, so having a robot inspecting the actual sewers, looking for structural defects and damages there, and then reporting that data to the workers so they can repair it. And the other is robots for comprehensive geriatric assessment, which is a test for elderly patients in hospitals to assess their abilities, the cognitive abilities as well as the physical abilities, and then come up with a treatment plan. So, and in CGA, as it is called for short, so the doctors found out that they and all the other people that are working in the treatment, they are doing a lot of time, they're spending a lot of time testing things, so filling in paperwork. And so they said, okay, why can't we use a robot for that? Just do the testing so we can spend more time with the patient actually. And now with the funds of ECHORD++, 6 consortia in total are developing robots, so 3 for the scenario of sewer inspection and 3 for the geriatric assessment. They're developing robots according to this very needs. So it's really in the end the users will have prototypes, small test series of robots they actually wanted and that are not commercially available on the market yet.
End user driven bringing of research to a product, taking that last step between research and prototype. Yes. and early stage use product, which is so hard. Bridging this, it's called the valley of death for a startup.
Exactly.
Is very challenging because private funds are not available because it's too early, and research funds can't be used because it isn't really research towards the end of that spectrum. So bridging this gap is very challenging, and you're working right there in that sector.
It is indeed, and well, one has to keep in mind. So with EU funds, you can't have you can't bring the product exactly to the market. So there is also a small gap where the funding for research and development has to end, and you need to bridge this gap to the market. So all the projects in ECHORD++ are going very close to market, but not on there. It's not that at the end of ECHORD++ you could immediately sell those projects. So that's where our network steps in, to be in contact with, for example, venture capitalists, to see, okay, they have a very interesting idea, so how can we actually access some funds to help them to bring their idea forward and to have a marketable product in the end.
Yeah, and there you work as an introducer, you work also as a credible third party. If you bring the startup to a venture capitalist and you can verify as a third party that's not interested in the deal directly and saying that this is good technology, we've listened to both the developers and the end users, and this is a substantial project.
Yes, our assessment is completely independent because we will not, we don't get a share of whatever revenue they will be making. So because we're working for public authorities like myself, the Technical University of Munich is owned by the state of Bavaria, so a region in Germany, and so I get my salary and that's just it. So
this is also very important, I think, because that streamlines the process both for the startup and also for the venture capitalist. Both of them have a very hard job of finding each other and finding the right fit.
Yes.
Do you see that venture capitalist is moving into this field, and is it easier now to talk to them than 2.5 years ago?
Well, there is one venture capitalist named Renaud Champion from France, and he's on the advisory board of ECHORD++, and I think it's still at the beginning to see the sector growing, that people are actually giving money for developing robotic startups. But I think it's an ever-growing market, and more people will step in, and which is a good thing on the one hand. On the other hand, of course, the startups need to be careful on whom to trust.
But you can also work as an advisor there, and of course, any venture capitalist would be very careful with the relationship they have with you, because you're here long term. You're going to be able to deliver them multiple projects over many years.
Yes.
And if they treat one of your startups badly, you won't recommend them again. So
that's true.
Again, being a trusted third party tempers everyone and
that's true,
fosters long-term relationships rather than short-term profits and gains.
That's true. I fully agree on that.
Yeah. Could we've talked about the assessment of the elderly, and we've talked about sewer inspection. Can you mention a few of the other projects that has been going on? You're free to talk about the older ECHORD plus ECHORD projects.
There is so much. There is so much to talk about in ECHORD++. So we also have research projects called experiments. These are small-scale research projects with a duration of 1.5 years and a funding of roughly around 300,000 euro each. And we now got 15 experiments up and running, and 16 others will join this summer. So more than 30 projects in total, and they're from various application domains. We have agriculture, medical robotics, industrial robotics, collaborative robotics. It's really a vast field, and you can see really the wealth of robotics research that's out there. One of the projects I mention fairly often is the Mars project, which is they're producing swarm robots for planting corn. And there is one big manufacturer of agricultural machinery involved, which is ECHO, also known under their brand name Fendt. So normally they produce huge tractors. And so the idea of this Mars project is to have the farmer decide whether he or she wants to buy actually a big tractor like before, which is has its problems of soil compaction, it's heavy machinery, and of course someone needs to run the equipment. Or to say, okay, we're going to have a swarm of robots here. The farmer can operate them from his or her tablet, and in the meantime do something else while the robots are independently actually planting the corn. So this is a product they want to bring to market and make it commercially available at a competitive price. And it's very interesting because there is, on the one hand, ECHO from the manufacturer side. There is also the Hochschule Ulm, so the University of Applied Sciences in Ulm in southern Germany involved. So you have the two worlds there, academia and industry, and they have a farmer who gives them their field as a test site. So they're planting.
All three players are there: the research, the business world, and the end user, the farmer.
Exactly.
And I'm thinking that the swarm compared to the regular tractor is in the long run going to have a very hard time competing. You mentioned soil compaction, fuel costs, and also inflexibility.
Yes.
Non-farmers rarely think about the time-critical things that farmers go through when they need to bring in this corn when it's finished. With wheat and other produce, we might have hours from ripe to ripe. So it's it's a very tight time window where they can actually go out and get it.
Yeah, exactly.
And with today's method, we actually have to get stuff that is not really ripe, because we can't go to the same field 4 times.
Yes.
For instance, apples and oranges and other things. A robot can pass the same tree many times and pick off the fruit that is best suited right now.
That's true.
And instead of having one big one, you can have many small ones. So should one break, it's not going to be the end of the world.
Yeah, that's true. So the idea is also that one of the robots, if it's malfunctioning, it can report, okay, I'm not working correctly, I'm stuck here somewhere, and the other robots will take over. So that's the idea. And there is just one obstacle. One of the engineers told me, working on the project, that farmers love big tractors.
I'm thinking everybody that's seen a big tractor, that's a machine with potential right there. But I guess they don't like to pay for them. So
yeah, well,
keeping the money and.
If the robots are cheaper and more effective on the long run, so I think
if the farmer can keep the money and buy a very nice BMW or a Mercedes, maybe we can convince them to go for the robot.
Maybe so, yes.
Yeah. Because a big tractor is a huge investment,
yes,
and also these combine harvesters that they use to bring the crops in, they're used a very small part of the time. The tractor is used all the time, right? Yeah. But the many other specialized machineries are used very rarely. And that's a huge capital outlay that's just unnecessary.
It's standing in the garage a lot of the time.
Yeah, I'm thinking 45 out of 52 weeks, right? So that was for the farmer and industry. Do you, ECHORD, also have any projects that we as private citizens might see soon for regular use?
Not that I would think of any everyday projects right now. So if you, but for example, if you are unlucky and have a stroke, we will have the Motore++ rehabilitation robot. So this is a device, a robot which you can use to restore the upper limb functionality. And they developed this robot together with some exercises on a screen, which I like to call them games. And I think it's much more fun to do this with the robot than to do it in the traditional way that it's done now. The rehabilitation, and it's also very small and portable, so it's also suitable for in-home rehabilitation.
What I understand when it comes to rehabilitation robots is also that the robot has endless patience, and it always does the correct movement, and it can also adapt to every particular patient's every particular time, because through sensing and computation it can detect that this movement is best right now for this patient. And of course it will do it until it's fulfilled its criteria. It won't grow tired, it won't go on, it's more consistent.
It's true. And you can also adjust some values to say, okay, for example, the level of stiffness, how much force feedback you get from the robot. And there is also, of course, the data that is assessed, how well the patient is doing, and then you can see how well the treatment for the patient is going in the long run. So there are a lot of advantages of bringing robots to that field, actually.
Very interesting, very interesting. So if one wants to participate, we have basically 3 groups here, or we have 4 groups. We have researchers. How can they participate in ECHORD++?
Well, there used to be open calls for proposals, but they are closed. So the money for that calls is already assigned. But we have the robotics innovation facilities. Our third pillar, RIFs, exactly. The RIFs are open to the public labs with high-end robotic hardware and software, as well as technical expertise that is available here. And so each and everyone that has a good idea how to automate a process, for example, in a factory, or how to improve an existing robot, create a new one maybe, or to make a test of a robot to see if a technology works outside of the own lab, can go to a RIF, ask for a RIF engagement, as we called it, and use the equipment there, talk to the people there, benefit from their knowledge, and go home with an idea of what you might do in the future. And the cool thing about it, it's, as we said, at 0 risk, because the first 6 weeks of the engagement are completely for free, paid for by the ECHORD++ project. And also we say we safeguard your intellectual property. So we don't want to rip you off or something like that. You get non-disclosure agreements, whatever you like. So the RIFs are really there to help people, and that's what they do. And so if you're talking about a research group, maybe they're at an obstacle and they don't know how to overcome it. They could go to a RIF and say, hey, could you help us out in that respect? So we're having this problem, what do you say? what should we do, and then the RIF people would evaluate that proposal and see how it fits in the scope of the RIF.
And also a company can come to the RIF and say, this is what we're doing now, but we just think it has to be a better way of doing it. Can you help us use robotics, maybe cooperating robotics, to improve our business?
Exactly. Even yesterday we had the managing director of a company here who's thinking about automating a part of their production. So they're handling distribution of mail order companies. They're handling the returns, for example, and they also have a so-called leather shop. So they're how could you say that they're putting catalogs in plastic packages, for example, together with samples and so on. So and they have huge production lines, and so the plant is located in the Czech Republic, and in that region it's almost impossible to find any more skilled labor because the market is really empty. Everybody has a job there, and they want to grow, but can't because they don't have the people to grow. So actually, one idea they had was, could we maybe introduce robots in the process to help us grow, to automate a part of the production? And it's very important here. Let me really emphasize that. So everyone will keep his or her job. It's just about what you can do on top of that,
and also improve it. I mean, you might not have to do the same repetitive movement. You might not have to lift that heavy things. For instance, in elderly care, lifting patients is very, very strenuous and simply breaks your body in the long run.
Exactly.
Right?
And the company I've been talking about, so they do have engineers, but they're not roboticists, so they don't know what kind of robots are available on the market, so which technology would actually be there. So I matched them with the RIF people yesterday and said, okay, what can the RIF actually do? And now the idea is to find out how the production works in their plant, and to have some RIF people there to evaluate the production and to give them an idea of what technology would be there to automate the processes, what would be feasible, and also what would be not be feasible from the current technical.
Very important to know before you go on this potentially expensive journey.
Exactly.
You don't want to bark up the wrong tree, as we say. I mean, knowing, and this is a challenging area for non-roboticists and even for roboticists. That is knowing what is feasible, what is kind of easy, and what is kind of hard, and what is not feasible. You want to stay in the feasible, easy spectrum rather than going somewhere else.
Exactly.
So that's how researchers can provide their technology to people. That's how people can access them. And I guess also, can you talk a little bit about how this introduction to VCs work? That is then for somebody in research that wants to start a company.
Yes, but that's something we do right now only for the projects that are already in ECHORD++. So we're not at the scale that we could do that for everybody, because that's not within the scope of ECHORD++. But it might be a future proposal, so you're giving me a good idea here.
Yeah, and a name has been mentioned before. That could be a good way, a good starting point.
Exactly.
Yeah. So now we know more about ECHORD++, and we know more about the European robotic scene. It's been fascinating to talk to you, and I'm sure we're going to do it again soon.
Thank you.
And to track your progress and the progress of the project that's in ECHORD++.
Yeah, thank you very much for having me here. It was a pleasure, and I hope to see you again too very soon.
This episode is sponsored by Aptomica. Everything you need in modular robotics. Or robots up close, what's going on in robotics, online and on the road. If you like this interview, don't forget to subscribe, follow us on Twitter, and subscribe to our email newsletter on robotsinDepth.com. You can also support the show on Patreon.